next topic is number of zeros in the product. This is very interesting topic, so please watch this video till the end. What we have to find? Number of zeros in the product. What is product? Product is nothing but the number or the result obtained by multiplying the numbers. Okay. If we add the numbers, we'll get sum. Product is the result obtained by the multiplying the numbers. Here we have to find the number of zeros in the product. Okay. For example, here 120. 120 is ending with 10. So only 10 in the end. And this 2400 is ending with 2 zeros. Here 3700 is ending with 37,000 is ending with 3 zeros. Now how many zeros in the end? How many zeros with this product is ending with? That we have to find. So to find the number of zeros in the end, is it necessary to find the product? I will take one example. 2 into 2 into 3 into 5 into 7. What is the product? 2 to the 4, 4 3 is 12, 60 and 420. So this product 420 is ending with how many zeros? Only 1 zero. But to find the number of zeros in this product, is it possible to multiply all these numbers? 7 to the power of 21 is a larger number. We have to multiply this 7 21 times. And here we have to multiply 21 9 times. Okay, time is not sufficient to multiply all these numbers, and it is not the right way to multiply and to find the number of zeros. See, this problem will be given only for 1 mark in SSC, and it is also useful in competitive exam. So to find the number of zeros in the product, we no need to multiply the product. Just use the logic. What is the logic behind this concept? Listen carefully. Here 420 is ending with 10. This 420 we can write 442 into 10. And what is the factorization of 10? 2 into 5. Okay. You know, 2 into 5 is 10. 2 square into 5 square is how much? 2 5 is 10, 10 whole square. 2 square into 5 square we can write 2 into 5 whole square, that is 10 square. So product is 100. Okay. Next, 2 cube into 5 cube is how much? 1000. So to get 10, that means to end with 10, we need one pair of 2 and 5. To ending with 2 zeros, to get 100, we need 2 2s and 2 5s. Okay, 2 pairs of 2 and 5. And 2 cube into 5 cubes, 5 cube gives 1000. So to know the number of zeros in the end, we have to find or we have to count the number of 2s and the number of 5s in the product. Okay. Here, I'm not going to find that large number. I don't want that product. We have to find only the number of zeros in the product. See here, 2 power 1 and 5 power 2. This 7 power 21, 21 power 9, 3 power 3, I'm writing as it is, 2 power 1 into 5 power 2. This product will not give any zeros in the end. Okay, 2 into 5 square. How many 2s? 1. How many 5s? 2. 2 into 5 into 5. So in this 2 into 5 gives 10 and another 5 will be left. So to get one more 0, we need one more 2. Is there any 2 here? Is there any even number here? No. So this product is ending with only 1 0. Because here what is the least power? 1. So this product ending with, this product end with only 1 0. Okay. So we have to find we have to count the number of 2s and the number of 5s. One pair of 2 and 5 gives 1 0 in the end. 2 pairs of 2 and 5 gives 2 zeros in the end. Or if there are 3 2s and 3 5s, then that product will end with 3 zeros. We will see one more example. See, in this example, 13 power 2, 2 power 2 into 7 power 2 into 5 power 4 into 8. So this product ending with how many zeros? we have to find the number of zeros in the end. So as I told you, to find the number of zeros in the end, we have to count number of 2's and the number of 5's. See, 2 power 2 and 5 power 4. 2 power 2 and 5 power 4. So generally 2 power 2 and 5 power 4. So minimum value in the power is 2. So this number is ending with 2 zeros. But see here, this 8 we can write 2 cube, no? Here 5 power 4. So count the number of 2's. Here number of 2's 2 square, but here 8 also we can write 2 power 3. This 2 power 3 also counts. 2 power 2 into 2 power 3, 2 to the power of 5 and 5 to the power of 4. Now what is the least power? 4 is the least power. So this product ends with 4 zeros. Okay. So before writing the number of zeros, you have to see each and every number. If number is prime number, no need to find. But sometimes they may give even numbers or composite numbers. If you write the composite number as product of prime numbers, the number of 2's or number of 5's may be increased. Okay. Next question is, find the number of zeros in the product of first 10 natural numbers. Here we have to find the number of zeros in the product of first 10 natural numbers. That means 1 into 2 into 3 into 4 into 5 into 6 into 7, 8, 9 into 10. Okay. Here we have to find the number of zeros in the product. Here it is not necessary to multiply all these numbers to find the product and to count the zeros. Simply just take number of 2's and number of 5's. Before that, here 4 is a composite number, 6 is a composite number, 8, 9, 10 also composite numbers. So write as product of primes. 2 into 3, this 4 we can write 2 power 2, 5, this one 2 into 3, 7, 8 we can write 2 power 3, 3 power 2 and 2 into 5. Okay. Now count number of 2's and number of 5's. 2 power 1 into 2 power 2, 2 power 3, 2 power 4, 4 plus 3 7, 7 plus 1 8. So 2 power 8, I'm not writing the remaining numbers here, only 2's and 5's. Next 5 and 5, 5 to the power of 2. Now tell me how many zeros in the end? Obviously 2, because to end with 8 zeros, 8 2's and 8 5's should be paired. But we have only 2 5's. 5's we have only 2, but 2's 8. So here this 2 power 8, 2 power 6 into 2 power 2 into 5 power 2. This 2 power 2 into 5 power 2 is 100. 100 into any number will end with 2 zeros. So this number is ending with only 2 zeros. We have to take least power. Okay. Next, I will generalize these 2's and 5's to find the number of zeros. See, if prime factorization is having 2 power m into 5 power n, this is not point. If prime factorization is having 2 power m into 5 power n, then this product end with m zeros. This product end with m zeros if m is less than n, and this product ends with n zeros if n is less than m. If m is lesser than n, then this product ends with m zeros. If n is lesser than m, this product will ends with n zeros. Okay, so this is a general form. Next, we'll continue the same problem. So instead of 10, if you take 20 natural numbers, see, I'm writing only 5 multiples. 15 and last one is 20. See, from every even number we can write 2. So number of 2's are more. So 5 will decide a number of zeros in the end. So from 1 to 10 we have how many 5's? Here 1 5, here 10 we can write 2 into 5, 15 we can write 3 into 5, and 20 we can write 4 into 5. Okay, so how many 5s? 1, 2, 3, 4. So 4, 5 to the power of 4 and 2 to the power of, this will be more than 4. So this product ends with 4 zeros. Okay, in competitive exam, no need to write all these numbers and finding the number of, counting the number of 5s. Directly you divide this number by 5. Okay, to find the number of zeros in the product from 1 to 20, you just divide by 5, you will get number of 5s. Okay, so number of zeros in the end equal to 4. Suppose if this quotient is more than 5, then what to do? See, same number, I am taking 30. Okay, product of first 30 natural numbers. In between there is 25 and 30. See, if you take 30 is divided by 5, what we will get? Quotient will be 6. So is 6 zeros in the end? Like previously, we have taken 20 divided by 5. So quotient is 4. So number of zeros in the end is 4. If product of first to 30 natural numbers, 1 to 30, if we take 1 to 30, if I divide this 30 by 5, I will get 6 as a quotient. So this number is going to be end with 6 zeros. This product end with 6 zeros? No. If you observe here, this 25 we can write 5 into 5. So up to here 4, 5, 6, and this 30 we can write 5 into 6, total 7 zeros. Okay. So remember, this 30 first divide with 5. What is the quotient? 5 6 30. Okay. Remainder is 0. Again, if this quotient is more than 5, first write 6 here. 6 is the result. So 6 zeros plus this 6 again divided by 5. 5 ones are 5. So whatever the remainder may be, here this number is not necessary to divide exactly. It may be 1 point something, but you take only the integer. So total 7. Okay, we'll take some more examples to understand very clearly. So directly I will tell you number of zeros in 85 factorial. What is meant by factorial? The product of natural numbers from 1 to 85. That means if we expand this 85 factorial, 1 into 2 into and so on up to 85. So to know the number of zeros in this product, divide this 85 by 5. What is the result? 17. Okay, first write 17. Again this 17 divide by 5. 5 3s are 15. Remainder is 2. So what is the quotient? 3. 17 plus 3, 20. So this product will ends with 20 zeros. We'll take one more example. 74 factorial. That means 1, 2, 3 up to 74. So to find the number of zeros here, divide this 74 by 5. 5 15s are 75. So 5 14s are 70. So remainder is 4. So take only this integer, 14 point something will get. Don't take the decimal value, take 14. And again this 14, how many times when divided by 5? 5 2s are 10. So 2 is less than 5. So 2 is quotient, 14 plus 2, 16. So this product ends with 16 zeros. Okay, simple. Take the last value and divide it by 5. If the quotient is more than 5, again you have to divide by 5. Then add them. Then we'll get the number of zeros. Okay, so this is a kind of problem. See, to end with 0, any product to end with 0, that product should have 2 and 5. See this 12 power n. If I factorize this 12, 12 we can write 3 fours, 4 is 2 square. So 2 square into 3 whole to the power of n. So if I simplify, a into b whole power n equal to a power n into b power n. So 2 power a power b whole power a power m whole to the power of n into 3 to the power of n. See, for any natural number n, 2 into natural number is some even number. So 2 power some and into 3 power some number. So to end with 0, there should be 5 also, because 2 and 5 will give 10. But here there is no 5 in the product. So this number, this 12 power n, is not going to be end with 0. Since there is no 5 in the product, this 12 power n will not end with 0. Next, is 6 power n end with 0? 6 we can write 2 into 3. That is 2 power n into 3 power n. Since there is no 5 in the product, this 6 power n is also not end with 0. 6 power n end with 6 only. Because 6 to the power of 1 is 6. 6 to the power of 2 is 36. 6 to the power of 3, 36 into 6 again ends with 6. So 6 to the power of n. 6 to the power of n is also ends with 6 only, but not 0. Okay. Next. Is 3 power m. See, 3 power m into 4 power n. 3 power m, 4 we can write 2 square whole to the power of m. So 3 to the power of m into 2 to the power of 2n. So 2n is even number, 2 power even number into 3 power some number. So here also there is no 5. Since there is no 5 in the product, this product is not going to be end with 0. But what about 5? Is this product end with 5? See, to end with 5, there should be 5 but not 2. See, 3 into 5 ending with 5. 7 into 4 into 7 into 9 into 5. Since there is no 2 but there is a 5 in the product, this number is definitely ends with 5. If there is 2 and 5, then that number will, the product will end with 0. If there is only 5s but not 2s, then the product will ends with 5. But here there is no 5. We have 2 but there is no 5. So this product will not end with 5. Okay. Now my question is, you just put your answers in the comment box. 92 factorial. How many zeros in the end? 92 factorial end with how many zeros? 100 factorial end with how many zeros? Okay. So this is, so please try to answer this and put in the comment section. Thank you.
Thank you for watching this video.